Hi everyone, we are Group 4 and our project is on the analysis and redesign of packaging tape dispenser. The team members are listed below. Product details. Description. A portable tool designed to hold, cut and dispense adhesive tape conveniently with one hand. Estimated production is 365,000 dispensers annually. The market share is 7.9 billion US dollars and the major players in the US are 3M, Uline and Tackett. Target customers. The primary target customers are the packing companies, movers and warehouses. Secondary target customers are the retail shops, e-commerce businesses and manufacturers. The CAD drawing of the packaging tape dispenser is shown on the right side. The price per unit is 20.25 US dollars per packaging tape dispenser. Here is an exploded view of all the parts that is used to manufacture a packaging tape dispenser. The fast analysis diagram is depicted as in the slide.
Based on the components of the tape dispenser, the fishbone assembly diagram is created. The first sequence is a conventional sequence which is used. In this sequence, the components move in a serial line and every component is attached directly to the base plate. This shows a small video of how the assembly sequence will be taking place. This is the second assembly sequence that has been formulated. This is an assembly diagram which uses different sub-assemblies which has been denoted by the branches. The three main sub-assemblies are tape dispenser front sub-assembly, tape dispenser holder sub-assembly, and the tape dispenser handle sub-assembly. These are the three sub-assemblies shown separately, and this is the final component. This is the assembly sequence comparison matrix, and from this matrix we found that sequence 2 is the better sequence.
Functional component mapping matrix, where the components of the product assembly is mapped with the leaves of the fast diagram. It is evident from the matrix that provide resistance and ensure flow have the most number of paths associated with them, which could improve the efficiency if the paths are consolidated.
This is the bill of materials of our product. It is worked out based on the assembly sequence 2 with 3 sub-assemblies. The total cost is $9.923, which is 50.2% less than the actual market price. Then the parts are classified based on their functional importance and manufacturing cost. It is concluded that 8 parts are in keep as it is position and 4 parts, namely base plate, tape holder, handle and metal plate, are in required to redesign position.
For the product family design, the functions that are going to be common between all the customer groups are going to be those functions that are necessary for releasing and cutting the tape, whereas the different functions are going to be those that relate to having a different appearance and different specific grips. This is similar in the component commonality table, where all the platforms again are simply those components that are necessary for cutting the tape, whereas the modules are going to be where the tape dispenser varies in style and grip.
For the product family design, these two designs accomplish the packaging tape dispenser's primary function, which is to provide, release, and cut packaging tape. However, noise generation is different among both of these designs. For the primary group, the environment is a lot more industrial and louder. As such, the design is built to be more industrial without really having much importance on noise generation. Meanwhile, the secondary group includes an additional roller to make the packaging tape quiet as it comes out of the dispenser, and is also built to be a little bit less industrial while still maintaining good structural integrity and holding the tape down. Here's a front view of both of these designs. And here is a trimetric view of both of the designs. And now here's a module comparison. So for the plate module, there is more material than the secondary customer design, and there's also an additional hole for a tape roll mounting beam. And the handle module is quite simple. It is just a flat piece of plastic. For the secondary customer, there is an additional hole for the quiet roller, and there's also less material than the primary roller. And for the handle module, there is an additional hole for a tape holder assembly beam, the part that holds the tape with the torsion springs. And here are the common interfaces. So there are 7 parts that are all common interfaces. they basically just like align the tape and use a roller to just help dispense the tape. The plate module interfaces with everything except for the torsion spring mounting holes, which is the piece shown at the bottom right, and the handle module only interfaces with the piece at the bottom right.
To add delay differentiation to the assembly sequence, we want to have the modules appear later. So in this assembly sequence, the base plate, instead of being mounted to initially, is now one of the last things to be added. And this is able to be done because it's not necessary to mount to it to be able to create the part. And this helps to allow to have different base plates for different customer groups later on. And similarly with the handle, again, it's not necessary for this to be mounted initially, so this can be moved much later, allowing for a delayed differentiation.